Hey guys, my name is Ron Baziaco, and in today's video we're going to look at a question that I saw. I heard from some people that it was fairly difficult, but I think that if you just kind of sit down and go through it, it's pretty easy. So I'm going to go through two kind of solutions. I'm going to go through one where I go through slowly and explain everything. Then after that, I'm going to go through this and the way that I did it for speed, because I know like in some tests or contests you need to be fast with this stuff, and so I'll show you how to get kind of there quickly and to just be able to know what connections to make. So we have all these equal octagons with side length A, and they're made into a shape like this, and it's asking for the area of the shaded region inside that I highlighted in green in form of p times 2 plus root 2 times a squared, where p is an integer. So I think it's important to note that every single side length of every part of the octagon is all going to be a, because it's an equal octagon, right? So just everything is going to be a. And I just think it's kind of, I don't know, important to remember just going through. So I look at this shaded region, and there's two parts that really stick out to me, and I'm going to highlight them right now. There's this big square, and then these four separate triangles outside the square. Now, with these triangles, we actually do know two of the side lengths, which are A. And we'd be able to figure out the area of the triangle in two ways. One, if we knew the height of the triangle, or two, if we knew that it was a 90-degree right triangle, then we'd know that the area would just be a squared over 2, right? Because it would be a times a divided by 2. So I'm actually going to try and find out the angles inside this triangle. And so I think there's a certain formula that's important to note. And it's that if you have any polygon... Oh my goodness, I spelled it wrong. The formula for every interior angle, it's going to be n minus 2 times 180 over n, with n being the sides of the polygon. So we know that it's an octagon, so it has 8 sides. So this is going to give us 6 times 180 over 8. And you can put this into your calculator. I've already done it. This simplifies out to 135. So I'm going to just kind of draw the octagon out here. So we know that all of these angles are 135, right? This is a 135, all 135, which makes sense just kind of by looking at it. But what that really tells us is that if you look at the triangle, right? I'm going to draw a green line like this. If we know that this is 135, then that means on the other side of this, this is 45. Okay, and so let's zoom in here. Let's see, I'll choose a different color. Let's zoom in. We know that this is 45. And we know that this is going to be 90, right? This creates a 90-degree angle. The square is going up horizontally or up vertically, and this is going over horizontally, which means that this angle right here is going to be 45. Now, we have our triangle, right? This is 45. And if you were to do the same thing with this angle, it would be 45 as well. And just using the angle identity, this third angle is going to be 90, right? Because you're going to go 180 minus 45 minus 45. And it's also an isosceles. So we proved that it's a 90-degree angle. Or this is a right triangle. And for right triangle, it's just base times height divided by 2 for area. Base and height are both a, so it's a squared over 2. However, if you count, there's 1, 2, 3, 4 triangles. So we really want four of these areas, which is going to be 4 times a squared over 2. We can cancel this out, giving us 2a squared. So the area of our 4 triangles is 2a squared. Now we just need to figure out this big square, whatever the area is. And I think this is going to be pretty easy to figure out. Let's consider just one of the side lengths of the square. Well, we know that this section right here is A. And this section right here is also A. But we need to be able to find this blue section. However, we know it's a 45, 45, 90 triangle, and we know the other 2 side lengths. So let's just draw this triangle out. Well, in a 45, 45, 90 triangle, it states that if you have any side length A and A, this is going to give you root 2 of A, the hypotenuse. And the way you get that is you can use the Pythagorean theorem. A squared plus A squared is equal to whatever the hypotenuse is squared. 2a squared is equal to hypotenuse squared. And then you can take the root of both sides. Hypotenuse is equal to the root 2, and then the root and the square and the a cancel out, and it just gives you this. So we now know that this little length here is going to be 8 times root 2. So we can simplify that side length. I'm just going to call it 2a plus a times root 2. And to find the area of that square, we're just going to square this, right? And so this gives us the area of the square. And if we know the area of the 4 triangles to be 2a squared, and we know that the area of the squares is this expression, then that means that total area is equal to 2a squared plus 2a plus a times root 2 squared. So this is really good. I think there's a bit more that we can do, though, because the question wants us to put it in a specific form. It wants it in a form of p times 2 plus root 2 times a squared, where p is an integer. So I'm just going to simplify this. So I'm going to focus on this because that 2a squared you can't really do anything with. Just looking at the inside, you can factor out an a. It's going to be a times 2 plus root 2 squared, which is just equal to a squared times 2 plus root 2 squared. If we look at 2 plus root 2 squared, we can use a plus b squared equals a squared plus b squared plus 2ab. A squared is going to be 4, b squared is going to be 2, so root 2 squared is 2, and then 2ab is 2 times 2 times root 2, which is 4 root 2. However, this is all being multiplied, distributed by this a squared. So this is actually going to give us 4a squared plus 2a squared plus 4 root 2a squared. And then I'll add on this 2a squared right here. I think right now I'm just going to combine all the terms of the a squareds that don't have a root, and you'll see why in a second. 4 plus 2 plus 2 is 8. As you can see, we can factor out an a squared. This gives us a squared times 8 plus 4 root 2. Almost in form, however, we need the inside to be 2 plus root 2. And if you can't tell by now, obviously we're going to factor out a 4, because 8 divided by 4 is 2, and 4 root 2 divided by 4 is root 2. So if we pull out a 4, this is going to give us 4 times 2 plus root 2 times a squared. And this is our final answer. It's in the correct form that we want, and it's the solution for the area. And this is how we got it. Now this is me going through a bunch of these different steps. And, you know, it's good and all, but if you want to go through this quick, I'll kind of explain to you the connections of what I made to be able to solve a question like this. So, you see this big shaded region, right? Obviously, you're going to have to break it up because there's really no formula for creating an area for something like this, you know? And you should be able to see this gigantic square. And you're going to have to expect that at some point, you're going to be able to solve for this length, right? Because without it, you wouldn't be able to solve for the area of the square. And immediately, you just have to make the connection that you can solve for these, I'll zoom in on it, you can solve for these interior angles and make these triangles into triangles where you can figure out every side length. And then from there, when you have every side length, you can just go ahead and calculate all the areas. And when you get to this position, you know that if you did everything right, it's going to end up in this form, you know, because when the question specifically asks for it to be in that form, you know that this entire big thing is going to simplify out to something in that form. And so from there, you just keep simplifying and you keep factoring stuff out and try and get it in that form, and then eventually we'll get there. Anyways, I hope you guys enjoyed the video.